Next up, we're going to look at what I would call a series parallel circuit problem, and this is because we have a combination of series and parallel resistors that we need to solve to find the voltages and currents. So this is the type of problem I'm talking about, and again, kind of typical exam question thing. So for the circuit shown, determine the magnitude and direction of the current flowing through the 30k resistor, which is this current over here we need to find, and also find the voltage drop across this 20k resistor here. And I've just drawn directions on there completely arbitrarily, okay, so I'm going to rub them out now because we don't know if those are right for now. So how do we solve this one? Well, first up, start with Ohm's law. We always start with Ohm's law. And what can we find? Well, first up, we can find this value IT, which is kind of given as a bit of a hint. So we can say that IT is going to equal to the voltage drop across it, which is defined as 30 volts, that's given in the question, over the value of the resistor, which is 6k, which will give us IT is equal to 5 milliamps. And what direction is it? Well, it's in the upwards direction because it's opposing the voltage, which is defined as being downwards. And it's easy to get kind of mixed up here because it's very unusual that we have voltages so far presented as being in a downwards direction. Normally it's the currents that do that, so just don't let that catch you out. Now that we've got IT, we can actually go about finding the voltage drop across the next bit of the combination. So remember when we talked about what happens to the voltage across these resistors. So resistors in parallel, if you've got the common voltage point here, which you're going to have, the voltage drop will be the same across this 30k resistor and across the 20k resistor. However, we don't know what that total voltage drop is at the moment, so the way we can find that is by combining these resistors. So instead of having, this is my top resistor, this is my 6k resistor at the top, and then two parallel resistors, we can actually combine those resistors to form a single equivalent resistance. So this is why we did all this stuff before. And in shorthand, we'd write that as 30k in parallel with a 20k resistor. And if you use your expression to find the parallel combination of 30k and 20k, what you get is that R parallel is equal to 12 kiloohms or thereabouts. So what that means is we know this combination. We also know the current flowing through it because we've defined this. This is IT, which we've calculated in this step above. And we can see that that current is going to flow through this parallel combination because we've combined it with this single equivalent resistor. Because we know that, and we know this value of Rp, that parallel combination, that means we can find this voltage drop, which you can call, I'm going to call Vp because it's the voltage drop across that parallel combination. So therefore Vp is equal to, just Ohm's law, is equal to IT times Rp, and we know all of these. So Vp is equal to 5 milliamps multiplied by 12 kiloohms, which will give us Vp is equal to 60 volts. And what direction is it? Well, it's downwards. I've drawn that on that diagram, and that should be hopefully quite intuitive from where I got that from. Remember, it's opposite the direction of IT is going on. So now that we know that we've dropped 60 volts across this combination, we can then calculate the individual currents, okay? So I'm just going to give myself a bit more space and go on to the next. So I'm just going to give myself a bit more space. So what we've got now is we can come back to looking at this combination. So we know that we've dropped 60 volts across this combination. So there's a 60 volt drop there and a 60 volt drop here. So we've solved part of this, but now that we know we've got that 60 volt combination drop, we need to find what I1 is because we are asked for this. And once again, it comes back to Ohm's law. So this time we want to find the current. So we can say that I1 is going to be equal to the voltage, which is 60, divided by the value of the resistor, which is 30k, which will give us a value of 2 milliamps. Finally, what direction is it? Because we're asked for the magnitude, which we've got, now we need to do the direction. So we know that the 60 volt drop is in the upwards direction, which means the current is in the opposite direction. So I1 is going downwards, and you can either write downwards or draw a little arrow just to show you know which direction it's in. And that's how you solve these types of questions. The voltage across the 20k resistor we've already done, because that was actually in the step that we needed to find I1. It would just, you can state it if you want as well. You can say V20k is equal to 60 volts in the upwards direction as well, because we're also asked for that. And this is how you solve these series parallel circuit problems. So try and simplify any parallel resistors into a single resistance and then go from there.